Welcome to Brain Vision.
To solve this question, we have to discover what is the angle theta. In order to do that, we can extend this horizontal line here to the other side. So that now we can decompose the tension force in two components. One horizontal component and one small vertical component. We can do the same with the wind force. It has one vertical component and one horizontal component. Let me call this tension force component Y, tension force component X, wind force component Y, and wind force component X. Note that this angle here in between the tension force component X and the original tension force is equals to theta, because we have two parallel lines that has one other line going through them. Therefore, this angle theta is equals to this angle theta by symmetry. So we can now exploit this symmetry to discover what is the value of theta. For that, we have to apply Newton's second law. We have two directions, the y direction, which is the vertical direction, and the x direction, which is the horizontal direction. Note that on the y direction we have the weight force, but we don't know what is the mass of the kite, so there isn't sufficient information to determine the weight. So, in order to go around this, we will use the horizontal axis, because on the horizontal axis there are only two forces acting, the wind force and the tension force. Then, Newton's second law tells us the following. On the x direction, the net force is equals to the mass of the kite times its acceleration in the x direction, which is equals to 0 because the kite is standing still. So the net force component x is equals to 0, but it's composed by two forces. We have the wind force component x, which is pointing to the positive x direction, minus the tension force component x, which is pointing to the negative x direction. Then, the wind force component x is equals to the tension force component x. And now note the following. We can use triangles to determine what is the relation between the x component and the magnitude of the force. For the wind force, we have this triangle. Here is the wind force, here we have the y component, and here we have the x component, and 56 degrees. Then, note that the x component is the adjacent side to the 56 degrees angle. Therefore, Fw component x is equals to Fw times the cosine of 56 degrees because it's the adjacent side. So, wind force times cosine of 56 degrees is equals to the tension force component x. For the tension force, we have another triangle, which is this one. Here we have the tension force component x, and the tension force component y, and here is theta. Note that the tension force component x is also adjacent to the angle theta. Therefore, tension force component x is equals to the full tension force times the cosine of theta because it's adjacent to theta. So we have tension force times cosine of theta. Now we can calculate what is the cosine of theta, and this is given by the wind force 19 times the cosine of 56 degrees divided by the tension force, which is 16. And then we can calculate what is theta. Theta is equals to the inverse cosine of all this. And then this is approximately 48 degrees. So now we can calculate what is the height of that kite. Let me organize the board to do that. So cleaning the board. Now let's do it. So the height of the kite is this orange line here. Note that we have a rectangle triangle here, and the height of the kite will be the opposite angle to theta, which you know that is approximately 48 degrees. Then, using this information, let's call the height h. We have the following. The sine of theta, which is 48 degrees, is equals to h, which is the opposite side, divided by 43 meters. Then the height is equals to 43 times the sine of 48 degrees. This gives a height of approximately 32 meters.